Good morning, students. Today we will have the discussion there on the another combinational circuit, that is subtractors. So the major focus that will be on the half subtractor and the full subtractor. Likewise, we have studied there in the previous video, which was based on the addition part with half as well as the full adders. So the first part of the discussion is half subtractor. Half subtractor is basically a combinational logic circuit, as I already told to you. Its basic purpose is for the subtraction of two single bit numbers. Like in this block diagram, you can see this half subtractor, just like the half adder, utilizes two inputs, let us say A and B, which are shown here, A and B, and then the difference of A and B, that is used here as an output, which is shown there as a difference D, and just like the adder, we were using the symbol C as a carry, but now in this case the term carry is substituted or replaced with the term that is borrow. So two inputs and two outputs. The term sum is replaced with difference. The term carry is replaced with the term borrow. The next part is how to do the design, or how the designing of half subtractor is basically done. Just like the previous video, we will have the discussion there on the designing part using some basic steps. The step 1 is identify the input and output variables. Like from the block diagram, we just came to know that there will be two inputs, A and B. They can be set or they can be used with four combinations. Let me write those combinations here. A, B, the first combination 0, 0. Second one will be 0, 1. Then third combination will be 1, 0. And the fourth combination will be 1, 1. So for these four inputs, we will compute the outputs. We will see the output, that is the difference D. And along with that difference D, we will take care of the another output, that is borrow, which is represented with the variable, or for borrow we are utilizing the symbol B. Now this is the truth table of the half subtractor basically. Like for the first row, when both the inputs are 0, 0, the difference is 0 with borrow 0. Similarly for second row, when the input A is 0, second input is 1, the difference is 1 with borrow 1. So it is that case, that is 0 minus 1. 0 minus 1. And when the third input is 1 for A and for B 0 is there, so we'll have the difference again 1, but now the borrow is 0. Similarly, for the last combination, that is 1 1, when both the inputs are 1 1, the difference is 0 with borrow 0. So this is the truth table that will help us in basically performing the binary subtraction between the two bits, two single bits. Then, just like the previous approach, we must be able to find out, or there must be some expression that should represent the basic operation of this circuit, that is half subtractor. So these are the two expressions which are basically followed up. Again, the XOR operation between the two inputs A and B. So here the difference D will be evaluated like A first input XORed with B. Similarly, the borrow is evaluated, or the borrow works according to the expression A bar dot B. So these two expressions that need to be used, that need to be taken care of when we are studying the full subtractor, or when we are studying the half subtractor. So they must be followed while evaluating the subtraction between two single bit numbers. So the last step is what will be the logic diagram, or how these operations, Boolean expressions such as for difference as well as for borrow, they can be implemented logically using the gates. So for evaluating a difference with an expression A XOR B, that can simply be implemented by using an XOR gate, single XOR gate. And for borrow, that is for the expression A bar dot B, we can use one NOT gate which is supposed to perform A bar, and then this A bar is going to be ANDed with the second input, that is B. So for that A bar dot B operation, we require an AND gate. And finally, you can see here, this is XOR, this is a NOT gate, and this is an AND gate. So you can see one XOR, one NOT, and one AND. They are sufficient enough to perform the difference as well as the borrow expression for this half subtractor. So before proceeding towards the full subtractor. Let me recall it again so that you should be able to learn. Half adder is basically a combinational logic circuit which helps in getting the subtraction between the two single bit numbers. So these two single bit numbers utilizes two inputs and generates two outputs. So this truth table we should be able to learn that for all the four possible combinations for two identified inputs, that is A and B, what will be the difference and what will be the borrow value. The step third is very simpler one. It is all about the Boolean expressions. So there will be two fundamental Boolean expressions that one must be able to learn, that D stands for difference and the expression for the Boolean expression for D is A XOR B. So we can also use the K-maps to generate the Boolean expression for this half subtractor. If somebody knows the K-map, it's good. Otherwise, you can directly learn the expressions. They are quite easy. So difference will be evaluated using XOR gate between the two inputs, and the borrow is basically represented as an Boolean expression A bar dot B. And the last step is about the logic implementation. How logically these expressions are implemented, which results to D, that is the difference, and B, that is the borrow. So from this logic diagram, it is very well clear that we require a single OR, single NOT, and the single AND gate.